The term algebra was the origin of the word algebra. Suppose A, B, and C are real numbers. If A is equal to B, then A plus C is equal to B plus C. This is a rule in algebra called the addition property of equality. Assume we have an equation x minus 3 is equal to 5. If we want to eliminate the negative term, we just add 3 on both sides of the equation. This is correct because of the addition property of equality. That is, x minus 3 plus 3 is equal to 5 plus 3. That gives us x is equal to 8. The adding of positive term or terms to eliminate the negative ones is called algebra in Arabic, which means restoration. And the adding of terms on both sides of the equations to retain the equality is called al-muqabala, which means balancing. Thus, before it was termed addition property of equality, it was then called as restoration and balancing, which became the title of the book Kitab al-Muhtasar fi Hisab al-Jabr wal-Muqabala, written in the 7th century by the Persian mathematician Abu Ja'far Muhammad ibn Musa al-Khwarizmi. It was translated then as the compendious book on calculation by restoration and balancing. The term algebra was the origin of the word algebra. Because of al-Khwarizmi's book and the mathematics in it, he is now considered by some as the father of algebra. However, obviously algebra did not start solely from him. It is hard to really tell the exact origin of algebra. There might be mathematical or algebraic discoveries even before the coming of the historians, archaeologists, and other experts that remained undiscovered and restored until today. Hence, we could only base the origin of algebra on the written records that reached the modern generation. The early Babylonians developed a positional number system that became vital in their ways of solving algebraic equations. However, the kind of algebra that they had was rhetorical. Babylonians were more concerned with quadratic and cubic equations than linear ones, and they were interested with approximations than finding the exact solutions to the problems. PLIMPTON 322 tablet was one of the most known written documents of the Babylonians where some advanced concepts in mathematics including algebra were recorded. Unlike the Babylonians, early Egyptians focused more on linear equations. The RHIND papyrus that was written by Ames around 1650 BC was the most extensive written mathematical document known today. It documented solutions to problems involving systems of linear equations. Ancient Greeks were much more famous on their works in geometry and astronomy than algebra. However, some solutions to their geometric problems were done using algebraic methods. That's why the algebra that they had was considered geometric algebra. Some notable names that made so much contributions in mathematical works including algebra were Thales, Plato, Thymaridas, Pythagoras, Euclid, Archimedes, and Apollonius. Euclid's Elements in particular was a treatise consisted of 13 books. Though the treatise was focused mostly on geometric problems and propositions, the approach to solve some of them were algebraic in form. For example, in Proposition 1, which is the distributive law for multiplications, states that if one of two lines is divided, the rectangle on the two lines is the sum of the rectangles on each of the parts and the undivided line. Nowadays, it can be interpreted as A times the quantity B plus C is equal to A times B plus A times C. Chu Chang Xuan Shu, translated as the 9 chapters on the mathematical art, is composed of 246 mathematical problems and is one of the most important Chinese records with regards to mathematics. One of the chapters discussed about systems of determinate and indeterminate linear equations. Si Yuan Yuqian, translated as Precious Mirror of the Four Elements, is another very influential book by a Chinese mathematician Chu Shiqi in 1303. This work became the peak of development in Chinese algebra. Many other written works that had been written by Chinese mathematicians that had great contributions in algebra. Arithmetica is a treatise written by Diophantus, a Hellenistic mathematician who lived around 250 CE. Arithmetica was composed of 13 books with 150 solved problems, but only 6 books have survived through time. One of the main aspects of Arithmetica was finding the exact solutions to algebraic problems, rather than simple approximations as being developed by Babylonian mathematicians. In Arithmetica, symbols were already used to simplify the problems, but not as thorough as the symbols used today. However, Arithmetica was so rich of algebraic concepts, problems, and solutions that made Diophantus being the father of algebra as considered by some mathematicians and historians. Diophantine equations are still being studied until today. Aryabhata and Brahmagupta were just few of the many Indian mathematicians who made major contributions in algebra and mathematics in general. Aryabhata's Aryabhatiya gave the rules for the sum of square numbers and the sum of cubic numbers, and many other series of numbers. Brahmagupta's Brahmasputa Siddhanta showed some algebraic ways in solving quadratic equations for both positive and negative roots. It was also shown in this book that Brahmagupta studied most of the problems written in Diophantus' Arithmetica. Both books had great influences in the study of mathematics in India. Bait al-Hikmah, or House of Wisdom in Baghdad, Iraq, which was established by al-Rashid al-Ma'mun in the year 830 AD, was one of the most notable places for academics where Muslim scholars studied sciences and mathematics. One of the scholars turned educator in this school of thought was Persian mathematician Abu Ja'far Muhammad ibn Musa al-Khwarizmi, who wrote the book Kitab al-Muhtasar fi Hisab al-Jabr wal-Muqabala, which became one of the foundations of symbolic algebra that we have today. One of the emphases of the book was solving quadratic equations using completing the squares. The book was the main reason why al-Khwarizmi is considered today by some as the father of algebra. After which, many other mathematicians have contributed in the development of algebra from any parts of the world, including the study and development of abstract algebra that discusses the concepts of groups, rings, and fields.